This presentation is on Chapter 8 in the book on intrusion detection systems. So there's an overwhelming need for intrusion detection systems, or IDS. They are designed to prevent intruders from trespassing in the system. Now you have different types of intruders. The book lists the following three. The first is a masquerader. That is someone who is an unauthorized user. Another one is a misuser. This person is a legitimate user. However, this person does not have the proper privileges. So this could be a regular user who's trying to become an admin or take on admin responsibilities and privileges. And the last one is a clandestine user. This is someone who could be a legitimate user or an unauthorized user, but they are someone who seizes supervisory control to evade detection. Now, the book also lists the possible threats to any type of security system, and we've talked about these in previous chapters, but I just want to quickly go over them so you guys can fully understand and hopefully appreciate the role that IDS plays in cybersecurity. So you have a hacker, and the hacker typically is trying to select some of the characteristics of a hacker. They're trying to select a target node using an IP lookup tools. They may be mapping networks to find accessible services. They may be identifying potential vulnerable services. Some cases, hackers will still use brute force to get your password. Hackers are also known to install remote administration tools. Hackers will also capture passwords by waiting for the administrator to log on and then use that password to gain access to the remainder of the network. Now, you think about a criminal enterprise. They are individuals who will act quickly and precisely to make their activities harder to detect. They typically exploit perimeter through vulnerable ports. They use a lot of Trojan horses to lead backdoors for re-entry. They also use sniffers to capture passwords. They don't like to stick around until they're noticed, and they make few or very little mistakes. So that's a good difference between a hacker and a criminal enterprise individual. And lastly, these are your internal threats. Your internal threats are people who already have access to the system, and they may create network accounts for themselves and their friends. They may access accounts and applications they wouldn't normally use for their daily jobs. Internal threats may sometimes email former and prospective employers. They may conduct furtive instant messaging chat. So this is reducing your resource capability and your throughput. They may also continue to do things like that to visit websites that, like Facebook or other social media websites that require a lot of your resources. They also may visit websites that cater to disgruntled employees. They could also perform large downloads and file copying. And lastly, they may access the network during off hours. So you have a lot of different threats going on. That's the purpose of this. You have several types of intruders, and then you have individuals who will threaten your system for a variety of reasons. It's very difficult to prevent all of this without some kind of a system, and that's why you have intrusion detection systems. Now, an intrusion detection system explained is typically just a security service that monitors and analyzes system events for the purpose of finding and providing real-time or near real-time warning of unauthorized attempts to access system resources. Now, the book didn't mention this part, but in my experience, an IDS is completely critical in today's cybersecurity. Any organization, if it's a professional organization, a business, a government agency, it's very important that you have an IDS set up. And if you guys are taking the jobs or the duties of a IT administrator, one of the first questions you would want to ask is, what IDS are they using, and you want to understand the parameters of how it's being used. And we'll talk more about that later in this chapter. So there are two types of IDS. The first one is a host-based, and the two differences are pretty self-explanatory. A host-based just monitors the characteristics of a single host. And you have a network-based, which monitors the network. There are situations where you will use a host-based IDS on your server, and then your network-based IDS to monitor everything that the server serves within that network. In other cases, you may do a host-based IDS on a single workstation that may be used by guests within an organization or things of that nature. But you guys need to know the differences and realizing what do you need to protect and what's the best way of protecting it. Now, regardless of what IDS you have, there are three key components. The book mentions two. The first is sensors, and the second one are the analyzers. And the third one I have listed here is the users. And the way I would like to describe an IDS is, think of a interstate highway where you have a lot of traffic throughout the entire day. So you have these traffic stops where you have police officers just monitoring the speed of the cars. And their job is to pretty much ticket anyone who's traveling faster than a certain speed limit, or anyone who's traveling who's driving such an odd behavior that it could cause accidents and things of that nature. So those police officers are looking for those type of individuals. So you have so in this case, the traffic on a highway represents a network traffic in a computer system or a network system. The police officers, they represent your IDS. The thing that they hold up to check the speed of a car that's passing them by, that's a sensor. The output that it displays on the screen is an analyzer. Or when the police notices a car driving erratically, that's another way to analyze it. And again, your police officers are going to be those end users where they can actually get in the car and then stop that traffic. So that's what they're doing. And that's how an IDS works as well. So you can see it's very important to have that end user be a part of the IDS. Without the end user, you're not going to, you can capture a lot of stuff, but you still won't be able to know what is going on in the system. And I want to explain that in the next slide. So, so an IDS is only good as the end user who's monitoring what is happening, or the end users. Another example is your basic run-of-the-mill security system at a business where they have videos and alarm systems, and you have a switchboard somewhere in the front desk area where you have a security cop, and he has a TV, and he's supposed to be watching the TV to see what's going on. Looking at also the switchboard, seeing any lights come on, because those would alert him to problems in the building. However, he's too busy reading a book, and he's not noticing what's going on, or he's asleep and not noticing what's going on. So you could have this state-of-the-art security system, but you still need somebody guarding and watching the videos or watching the output of that system. Same is true about intrusion detection systems. So due to the complexity in cyber activities, these systems must be able to understand how to visualize information to the user. And this is where human factors comes into play. This is a term that isn't particularly mentioned in your book with a lot of detail. And I just want to quickly go over it because it's important to understand the user if you're going to be in an IST class. So this goes back to making sure that the user can understand how the system functions, understand what the system is doing, and be able to make accurate decisions based upon what the system is doing. So in this case, you want to make sure that the information is organized because cyber activities are very layered, multifaceted, very complicated. So therefore, you want to present this information to the users in an organized way. It needs to be brief, but at the same time, allow the users to get to some specific details about particular events. And it needs to be actionable. That user needs to be able to act upon the information that's given. So we're going to talk about this more now. So now these are some examples of bad IDS systems. So this is one of the earlier forms of an IDS where it was just text-based. And you can't really see what's going on here, but essentially every event, so this is almost every car on the highway, is given an ID and some type of user tag, and is labeling all the parameters to that event. So in this case, you'll get the port number and whatever is going on, the communication back and forth between in that port. And you do that for all the different events that are going on. So that's for all the different cars on a highway. Well, you guys may be able to understand or see that that's a lot of text that a user would have to actually digest. And as a result, they're reading so much that they're probably losing awareness in the total system. Something else can happen that may require their attention, but they're too busy reading a particular line elsewhere. Another problem with this, it requires the user to memorize what's going on, which of course will decrease over time because this is a snapshot of all the events for a particular second. The very next second, this information will be different. So, then it changes the second after that and the second after that. So the user is going to be required to have to memorize all this stuff that's going on. Now, of course, a lot of an experienced IT administrator who is extremely familiar with that system, with the system, they typically already know which nodes to look for. They know which port numbers to look for, which IP addresses to look for, because they're typically the bad ones, or at least the ones that are most vulnerable. But if you bring in someone who's new and it doesn't have that experience, then you create these kind of issues where they're relying more upon this IDS than their own understanding. And that's why this is a bad example of an IDS. Now here's another example of a bad IDS. So this is where there's a lot of details in this snapshot. It's very easy for the user just to fixate on one set and ignore the rest, which is bad because what that person is looking at a particular time may not be what he should be looking at because something of a higher priority may be occurring. There's also some misplaced salience here. As you can see, there's a lot of colors going on, and when you have too many colors going on, it actually decreases the message you're trying to convey with these colors. In this particular case, we always generally associate red with bad, green with good, and as you can see, there's a lot of red. But does that mean the system is that poor? I don't think so. So it's really something that's hard to tell by using so much colors. And finally, here's another example of a bad display. So in this case, you have a few things going on. First, you have a lot of complexity to this display, and it really makes it difficult for the user to develop a pure mental model of what's going on. The user has to click on things to see things, click on a screen underneath another screen to see the information that's on that screen. They may actually not develop the proper mental model that's needed at every single snapshot. There's a lot of data overload going on here, and that reduces how much the human can actually process. So you have a few bad things going on in this display. Now we'll move on to a couple examples of good. So now in this display, you can see that this information is laid out in a very organized fashion. In the upper right hand corner, there's a network map. So the user can actually see how the network is laid out geographically. It really is helpful to the person to understand where the network sits in the physical world. It uses colors correctly, so you can see the bad ones, the ones that may be warnings. The bad ones are represented by red, the ones who may be warnings, which are represented by yellow, and then the good ones, which will be represented by green. They actually have the red ones on top so that the user can quickly get to that information, because that's what they're most concerned with, are the ones that are red. And lastly, there's a nice flow to the information. So where your upper left-hand corner is your very overview information, and then as you move down, it's still overview, but it becomes more specific, and as you get to the right, it becomes even more specific. So there's a nice flow in that particular case. And finally, here's another example of a good display. Now this particular display is from the new version of Snort. Snort is something that is one of the more popular IDS systems that is used. It is also referenced in your book. And more than likely, if you guys get a job in this type of work area, you will be using Snort as well. So in Snort, you can see here they have another good way of organizing information. Using global indicators, that's what that stoplight on the far left is. They're showing that globally speaking, green is good. You may have some bad events going on, but overall the system is malfunctioning above a certain threshold. And at the very bottom you have those graphs. Those graphs make it very easy for an end user to interpret and process. They can see the performance of each of the nodes, and they can see the attacks and how often the attacks are occurring within a particular time frame. So hopefully you guys are getting a better understanding of an IDS and the role that human factors play in being able to present that information to the end user of an IDS, so that if you guys actually were to get employed in this type of area, you would be more mindful and considerate to find tools such as Snort that will help you do your job much better.